days here in Madrid, but unfortunately it's coming to an end slowly. It's been great. My name is Nicolas, and I come from Uruguay. I'll be talking to you about the NSX integration into CloudStack today. I'll try to give it a brief overview of what we have been working on this feature. You may be thinking, yeah, there's been all this hype to get out of VMware, and now we have introduced support to NSX, to VMware NSX into CloudStack, and that's true. But yeah, we have, as a product, we still support a various range of hypervisors, and one of them still is VMware. So I think this is a very good feature for the VMware support. So we have been working on this feature which introduces VPC functionalities in CloudStack with NSX networking. Let me see if this works. Yeah. So what are we going to go through today? First of all, a very brief introduction to SDN and the main concepts of NSX and its architecture, and then how to integrate NSX into a CloudStack zone, and how to create VPCs to use the functionality we have developed, and hopefully a short demo to show you how it's working. So yeah, about me, I'm a software engineer. I work at ShapeBlue since 2017. I'm a CloudStack PMC member and also a committer, father of Milagros, and I'm a tennis and football fan. So let's see. Yeah, there it is. Okay, let me go through this slide better, if this works. Oh, let's see. Oh, there it is. Good. So yeah, a very brief overview of SDN. So what we have on your right side would be the traditional networking, in which there are some network devices running the control plane and the data plane together. So basically, very briefly, and you would know better than me, what we try to do with SDN is to decouple the control plane to the data plane. So basically, instead of having all the control plane into every single network device, the objective of SDN would be to decouple the control plane and data plane, leaving the network devices such as router switches, making only forwarding packages. So that's the main goal, and you have a centralized controller which interacts with each network device by the data plane, and yeah, by that you have the decoupled architecture, and you're able to add programmability to your SDN solution. So what we have in CloudStack, there are some various SDN implementations supported, and the most recent are Tungsten Fabric since 4.18, VMware NSX, what I'll be talking about today, and in future Netris. There's been some talks from the Netris guys, so hopefully we'll have the support into CloudStack soon. All right, so VMware NSX, on a very high level, we have the NSX manager in control of the management plane and control plane. So from the NSX manager, you control the UI, it exposes an API, and controls the flow to the data plane. And in your data plane, you can use the ESXi hosts containing the NSX module to be used as transport nodes. You can also use these NSX edge nodes, which are special virtual machines to deal with the data plane. So that's a very high-level view. Let's go to the next. Oh, I'll better do it from here. Yeah, okay. So that's the basic interaction you have. And yeah, the data plane is handled by these special types of hosts or edge zones. These edge zones are special appliances, as well as the NSX manager, which is from which CloudStack will interact to NSX. So there's also the typical multi-tier deployment, which will follow in this integration. Basically, the administrator will need to set up a tier 0 gateway, which is the logical router in charge of the north-south traffic. And then every tier 1 gateway that will handle all the segments, will be like tenants for every VM, will have a different tenant. So CloudStack would be in charge of creating these tier 1 gateways for each VPC. And they will all connect to a single tier 0 gateway on each zone. And that's basically the high-level design from a developer point of view. If you will see there's been more people involved, so if you have more architectural questions, we can see later. So let's go to the next. CloudStack also requires to set up, as we'll see later, the concept of a transport zone in NSX, which is basically a zone containing transport nodes. And each transport node would be like either a VLAN on each HVM or host, which allows you to connect VMs on different hosts to the same overlay or VLAN. So basically, they can be on different hosts and still communicate. And that's also a thing to be pre-created by the administrator on the NSX side. And finally, the integration. So there are some prerequisites, as I mentioned. Let me go from the first. First, you need to deploy an NSX manager cluster. What is that? An appliance which you have different types of offerings. You'll need to deploy them. Typically, a production cluster would be 3 NSX managers. For our test, we use only one, but could be only one manager, sorry. But you could form a cluster. And from this manager, all the APIs would be exposed, and CloudStack will interact with it. So then you'll need to register your vCenter on the NSX manager and configure either the hosts you're going to use for transport nodes here, and deploy also certain instances, which could be the edge zones for the data plane. And with these edge nodes, you'll create an edge cluster. And that's the final thing you need to pre-create before integrating it into CloudStack. So with those things, now you're able to create a CloudStack zone which connects to NSX. So some key points for this integration. It is supported on 4.20. This version would be available soon. Only supports VMware and supports NSX version 4.1.0. So on this work, we have worked with Alex, who's been the architect, Lucian, who has tested, and Pearl and me, who have developed it. So if you have some questions, can also reach them as well. Let's see. So what have we introduced on this integration? VPC functionalities in CloudStack should support ACLs, network tier routing, user data, SSH key injections, DNS, DHCP, and Kubernetes support on VPCs. That's and load balancing, sorry, because without load balancing, this won't be possible. So all of these features are supported, and I will try to show you how to set up a CloudStack zone with NSX isolation. Okay, there we go. There are some global settings that needs to be One needs to be enabled, but because by default, the plugin is not enabled, so you need to enable it, and then you just need to double check the management network group, port group, for each host. And after that, you need to take into consideration these two things. The first thing, physical networks. So you will need at least 2 physical networks. One will handle the guest and public traffic. This one should be NSX isolation type in CloudStack. And the other one should handle management traffic, which should be a VLAN. They both will be in distributed vSwitches, but it's important that the guest and public traffic has the isolation type NSX. And then we'll see that we'll need 2 public IP ranges, one that will be used only for system VMs, and the other for VPC services, such as NAT, port forwarding, load balancing, etc. So let's see how this looks in a zone creation. So we have some differences on a typical CloudStack zone deployment. The first thing, as I mentioned, you need 2 physical networks, and the first one needs to be guest and public traffic. So once you have set this up, you will see there are new steps that you need to complete: NSX provider, public traffic, and NSX public traffic. Those are the 2 additional public traffics that you need. So let's see. We start with the usual management traffic. This will just create private port groups for system VMs. So all your system VMs will use the private or management traffic on this DB switch. So you need to set up the DB switch, you pass the VLAN ID, and CloudStack will create the system VMs there. And for the public and guest traffic, let me show you. Yeah, you pass the second distributed vSwitch, you then pass a VLAN ID, and you set it to distributed vSwitch. So on that distributed vSwitch, NSX will be creating the NSX segments for each network tier. And the VMs will be attached to these NSX port groups or segments, actually. And that's what we need to do by linking the NSX controller or manager to CloudStack. So you pass the IP or the DNS name of the NSX provider, your credentials, and you pass the three elements that we have seen earlier: the edge cluster, the tier 0 gateway name, and the transport zone. So with those 3 elements, plus the IP or DNS name and its credentials, it's necessary for CloudStack to interact with the NSX manager. And finally, the last 2 public IP ranges. So as I don't know if you can see here, there are different tags for the public traffic. One says system VM, and the other says NSX. Okay, so when you add the first one as a typical public IP range, then this will be tagged as system VM, as it's the first traffic, and the second one would be tagged as NSX. So every system VM will be consuming their public IPs from this range, from the first one, and every VPC public IP you'll need for your services will be from the second range. And that's about it. So in summary, you need these 2 physical networks, the 2 public IP ranges, and a bunch of information about the NSX manager. Looks easy. So now let's see how this works for VPCs in CloudStack, having created your NSX zone. So the virtual router still exists, but it's not the gateway for the VPC. In that, the tier 1 gateway that will be created by NSX will act as the usual CloudStack virtual router. So the gateway will actually be the tier 1 gateway and not the virtual router that CloudStack creates. The virtual router will still be there because still provides some functionality like SSH key injection, password injection, and user data. So we need it, but it's not a gateway. So you'll find it connected to your guest, to your VPC tiers, but all the routing will go through NSX. And this is like a typical VPC deployment with 3 network tiers. I have created this in CloudStack, and I will show you in a short demo that I have pre-recorded. So you'll see there at the top, it says Zone A Tier 0 gateway. That was a pre-created tier 0 gateway, which then connects to the internet. So that is what the administrator needs to preset and pass to CloudStack. So then, this is the VPC tier 1 gateway. You'll notice it has a strange notation. It says V1, A2. Okay, so it says domain ID, account ID, zone ID, VPC ID. So each VPC has the internal ID in CloudStack. So they have this strange notation to make it different. And here are the VPC network tiers. And we use S as it is an NSX segment. And these also are the IDs of these segments. And from here, all your networks will be connected to this segment. Let me show you, because I have pre-created the same thing we have seen here. I have it on this small demo. All right, there's the VPC, and we'll see there are 3 tiers, tier 1, tier 2, tier 3. The broadcast domain type is NSX, and you'll notice there are different ACL types. So I have pre-created this custom ACL, and the other 2 are allow all. So that custom ACL, I will show you how it got before doing that, that is the same picture, but on the NSX manager. And now I'll show you the ACL and how it's supported in NSX. So it has only 2 rules, opening port 80 and denying port 22. Okay, just a small test. So then we'll see how it gets mapped into NSX. There it goes. That would be the 3rd segment. No, that one. Okay. Segment 235. So in the distributed firewall, CloudStack creates a bunch of rules. And for 235, you see it created a group in which the source is any and the destination is the group itself, the network tier. And it mapped HTTP and SSH. But if it is a port that it doesn't know, it's not a well-known port, it will create a new one and will put it there. And it has the action allow and the other action drop. So that is how ACL works on the NSX side. Right, let's go back to CloudStack. Okay, another test. Yeah, those for default allow. Okay, should have the allow all. Yeah, allow from any to the tier, and from the tier to any, it allows everything. Right, so that's fine. Then we'll see a port forwarding rule creation. So we have the source NAT. Before that, we'll see the source NAT IP of the VPC is created as a NAT rule. You'll need to find the corresponding VPC, and there you have the same IP created as a source NAT. So then you can use, like a usual CloudStack port forwarding creation, you acquire first a public IP, and then create the port forwarding rule. Same thing will apply for load balancing, but I will do it for port forwarding. Okay, so that's from the CloudStack side. And we'll see what happens on the NSX side. So for the same VPC, I'll refresh and I'll have a DNAT rule from port 22 to port 22, from the public IP to the private IP. Okay, so that's basically a short demo, only for port forwarding, but you'll figure out it's the same logic, but on a different place for load balancing and other services which are supported. So, coming to the end, we'll have support in CloudStack 4.20 for NSX 4.1. And please look at the documentation because it explains more about the services supported, the notation, and what it is supported. It also explains how to create the zone as we have seen. But yeah, take a look. And we have also added support for isolated networks, which follows the same rules as VPCs with one network tier. And finally, but not the least, CKS is supported on VPCs. So give it a try. And yep, that's been the talk. So.
Thank you, Nicolas. Any questions from the audience?
Does it support both NSXT as well as NSXV, or is it just one or the other?
I think only NSX 4, right?
They dropped TLV, now it's just NSX 4. Oh, okay. So that's what it supports. Or, yeah, it's based on V. It might. Okay.
So it is agnostic to VMware now, like it is independent of VMware, the NSX 4?
So we built it on NSX 4.
Yep.
So it might work on V. Because we haven't tried.
Okay. Right.
Yeah, only tested on 4.1.
Okay, more questions?
Thank you, guys.
Thanks, Nicolas.